Hello everyone and welcome to the course on AI 050. My name is Smith Shah and I will be your mentor for the entire course. I'm a Microsoft certified trainer. On top of that, I'm a Azure certified data engineer. I'm a Azure certified data scientist as well as a Azure certified AI engineer. And I've been in the data science and AI field since the past 6 to 7 years, wherein I've delivered training to multiple international as well as corporate clients including Deloitte, LTI-Mindtree, Capgemini, Walmart, and many more. So that's just a brief introduction about me. Now let's dive into our course. So in our first video of the course, we will get to learn about the basics of AI. So let's start off. So what is AI? So most of you would probably know that AI stands for artificial intelligence, right? Full form of AI is artificial intelligence. But what is it? So guys, AI is nothing but a set of tools that is used for two purposes. First purpose is to get inferences from data. Second purpose is to get predictions from data. By inference, I mean getting insights from data. By prediction, I mean trying to know something about the future. So let's say based on how it has rained till the year 2023, I want to predict how it will rain in the year 2024. That's an example of prediction. So from now onwards, if anybody asks you what is AI, you will say AI is nothing but a set of tools that is used for two purposes. First purpose is to get inferences from data. Second purpose is to get predictions from data. Now you might ask me that, okay Smith, but how do we do that? How do we get inferences and predictions from data? So guys, we do that by using something called a AI model. What is this AI model all about? So let's look at the definition of a AI model. When I will show you the definition, it will look complex at first, but don't worry, we'll try to simplify it. So what is a AI model? A AI model is nothing but a statistical representation of a real world process. Let's understand this definition in a simple manner. So, suppose guys, I have information about some of the houses in my locality. So, let's suppose I have information about area of the house in square feet, and I also have information about the price of the house. Let's say the first house that I surveyed had an area of 100 square feet and the price of the house was, let's say, $1 million. The second house that I surveyed had an area of 200 square feet and let's suppose the price of the house was $2 million. The third house that I surveyed had an area of 300 square feet and the price of the house was $3 million. Now, I have a question for each and every one of you. Let's suppose I have information about a fourth house. The area of that fourth house is 400 square feet, but I don't know the price of that house. I want you guys to help me predict the price of the house. So, you guys would say that, okay, looking at the data on our screen, it feels that if we have a fourth house with us whose area is 400 square feet, the price of that fourth house would roughly be around $4 million. So you guys have given me a prediction. In order to arrive at this prediction, did you guys use some mathematics in your head? Did you guys use some statistics in your head? Yes, right? You did use it. So just like you guys try to use statistics or you guys try to use mathematics to simulate what would happen in the real world, similarly a AI model will also do the same. A AI model will also tries to use AI model will also try to use statistics or will also try to use mathematics to simulate what would happen in the real world. So up till now we have covered two definitions. First definition was that of AI. Second definition was that of AI model. Now keeping in mind these two definitions, let's proceed ahead. Now guys, in order to create a AI model, there are two important notes that you need to keep in mind. Let's look at them. So first important note is that for making any AI model to work, you need some data and that data needs to have some rows and some columns. Second important note is that the columns in the data will be of one of the two types. Either a column will be called a feature column or a column will be called a target column. Feature columns are those columns that help me to predict. Target column is that column that I want to predict. Let's understand the difference between a feature column and a target column. with the help of an example. So suppose I have data of some of the houses in my locality. Here is the data shown to you on your screen. Now we want to understand the difference between a feature column and a target column. We know feature column is a column that helps me to predict, whereas a target column is a column that I want to predict. So if I want to predict on price, then price will be which type of column? Price will be my target column. And since square feet and city help me to predict price, they will be called my feature columns. So remember, a column that helps you to predict will be called your feature column, whereas a column that you want to predict will be called your target column. Any other columns apart from feature and target are useless columns for us, and we need to remove them from our data. Alright, now let's proceed ahead. Now let's look at the different approaches to create a AI model. First is the approach of machine learning, second is the approach of deep learning. Let's have a simplistic difference between the two. So guys, machine learning is like using a knife, whereas deep learning is like using a machete. So let's take an example. Suppose I want to cut simple objects like a potato or a tomato or apple. In that scenario, which is the tool that I would use? Will I use a knife or will I use a machete? Well, technically I can use both. I can use knife and a machete both. But which is the tool that will be ideal for me? So in order to cut simple objects like a potato or a tomato or apple, which is the tool that will be ideal for me? You guys would say that knife will be ideal. Similarly guys, while working on simple data sets, machine learning is ideal. So on data sets wherein the relationship between feature and target is easier to understand, on such type of data sets it's better to apply machine learning. Let's take another example. Suppose I have a complex object in front of me, something like a coconut. So in order to cut a complex object like a coconut, which is the tool that I would use? Well, technically I can use both a knife as well as a machete. But in order to cut a complex object like a coconut, which is the ideal tool out of the two? So you will mention that machete is more ideal. So just like in order to cut complex objects, you chose something like machete. Similarly, guys, in order to work with complex data sets, it's better to use the deep learning approach. So this is the first difference between the two approaches, that machine learning is more ideal for simple data sets, whereas deep learning is more ideal for complex data sets, right? Alright, so an example of complex data set would be something like image data. Let's say I have two columns in that image data. One is my feature column, other is my target column. Okay, and across each row I have information about different images. In row number 1 I have information about first image, in row number 2 I have information about second image, and so on. Let's say in row number 1 I have information about pixel values of image 1. Okay, pixel values of image 1. Okay, and in the corresponding row of the target column I have information about the sentiment of the person in that image, whether that person was happy, sad, or showing neutral emotion. Okay, so let's say I have scenario like this, wherein I have two columns in my data, one feature column and one target column. In my feature column I have pixel values of the image, and in my target column I have information about the sentiment of the person in that image, whether that person was happy, sad, or showing neutral emotion. Let's say we have data like this. Now in this data, is the relationship between feature and target simple to understand, or is the relationship between feature and target complex to understand? So looking at the pixel values of the image, remember every image consists of pixels, and each pixel has a value between 0 to 255. So looking at the pixel values, will you know whether the sentiment of the person in that image is happy or sad? No, looking at pixel values, it will be difficult for us, right? So currently the relationship between feature and target is complex to understand. So on such type of data sets, it's better to use the deep learning approach. So first difference between machine learning and deep learning is that machine learning is ideal for simple data sets, whereas deep learning is ideal for complex data sets. Let's look at the second difference. Okay, so when I was giving you that analogy of a knife and a machete, I had asked you that in order to cut a simple object like a potato or a tomato or apple, which is the tool that you would use, a knife or a machete? And you answered knife. What were the reasons behind it? So one reason was that knife is simple for you to use, right? Similarly, guys, machine learning approach is more simple to implement. So if at all you are creating a AI model using machine learning approach, it will be more simple to implement as compared to a deep learning approach. So let's say on the same exact data, if you are trying to create a AI model using machine learning approach, it will be much easier for you as compared to creating a AI model using deep learning approach. So that is the second difference between machine learning and deep learning. Let's look at the third difference. So when I was giving you that analogy earlier of a knife and a machete, I had asked you a question that in order to cut a simple object like a potato or a tomato or apple, which is the tool that you would use? Will you use a knife or will you use a machete? So you guys said that okay, in order to cut a simple object like a potato or a tomato or apple, you guys would use a knife. What were the reasons? One reason was that it is simple to use, knife is simple to use. What is the second reason? Second reason is cost, right? Knife is more cheaper for you to use. So let's say you want to cut a simple object like a potato, you would go into the market and buy a knife. Okay, why not buy a machete? Because one thing is knife is simple to use. Second reason for using knife is it is much cheaper for you to use. Similarly, guys, creating a AI model using machine learning approach will be much cheaper for you. Why? Because if you create a AI model using machine learning approach, it involves less number of CPU computations. So let's say you are trying to create this AI model on cloud. Nowadays, most of the people try to create a AI model on cloud servers. Now on cloud servers, more CPU computation you do, the more cost you have to pay, right? So what I am mentioning over here is that if you are creating a AI model using machine learning approach, it has comparatively less CPU computations involved, because of which your computation cost on the cloud server will be less. On the other hand, on the same exact data, if you try to use or if you try to create a AI model using deep learning approach involves more mathematical computations on the CPU, because of which your computation cost will be high. So this is the third difference between machine learning and deep learning. Okay. However, the fourth and last difference to note is about performance. So if I ask you, in case of cutting performance, which is the tool that is more ideal? Okay, which is the tool that has more performance for cutting? Will machete perform better in cutting, or will a knife perform better in cutting? You guys would say machete will perform better in cutting, right? Similarly, guys, a deep learning approach, if you try to create a AI model using deep learning approach, creating a AI model using deep learning approach will give you higher performance or will give you higher accuracy in terms of predictions as compared to a machine learning approach. I repeat myself, if we try to create a AI model using deep learning approach, that AI model will have better accuracy in terms of making predictions. Okay, whereas on the same exact data, if we try to create a AI model using machine learning approach, it will have comparatively less accuracy in terms of making predictions. Okay, fine. So this is just a simplistic overview of the two approaches. So there are two main approaches to create a AI model. First is the approach of machine learning, second is the approach of deep learning. Now let's proceed. Let's understand the different types of AI models. So remember, guys, that there are many types of AI models. After 8 to 10 months, almost a new type of AI model comes into the market. But 95% of the work done in the AI industry nowadays is done on these two types only. First type is called supervised learning model. Second type is called unsupervised learning model. So for this lecture, we'll only focus on these two types. But remember, there are other types of AI models also. But for this lecture, let's focus only on these two types. First type is called supervised learning model. Second type is called unsupervised learning model. What is the difference between the two? Well, in case of a supervised learning model, the data that I am using has features and target both. Whereas in case of an unsupervised learning model, the data that I am using only has features, it does not have target. Now, supervised learning models are further divided into two types. First is classification, second is regression. What is the difference between the two? Well, in case of a classification model, my target column has finite set of possibilities. In other words, your target column has limited set of possibilities. On the other hand, in case of a regression model, your target column has infinite set of possibilities. In other words, your target column has unlimited set of possibilities. Let's understand the difference between a classification model and a regression model with the help of an example. So suppose I have a column with me called dice roll, and what I am doing is I am playing a game of dice with my friends, and whatever value I get after rolling the dice, that value I am storing it in this column. So let's say when I first roll the dice, I get the value 6. Then when I roll the dice, I get the value 1. After that, when I roll the dice, I get the value 4. Then again when I roll the dice, I get the value 6, and so on. So let's suppose I have this dice roll column. Let's say this column is my target column. So if dice roll column is my target column, then in this target column do we have finite set of possibilities or infinite set of possibilities? Well, you would say that in dice roll column I have only 6 possibilities, right? When I roll a dice, I can either get the value 1, 2, 3, 4, 5 or 6. Apart from these 6 possibilities, I don't have anything else, right? So in dice roll column I have finite set of possibilities, that means limited set of possibilities. So if dice roll column was my target column, and if in my target column I have finite set of possibilities, then my model will be called a classification model. Let's take another example. Suppose I have a column with me called gender, and what I am doing is I am storing the gender value of every employee in my office. Let's say the first employee in my office had a gender of male, second employee in my office had a gender of female, third employee in my office had a gender of female, and so on. Now let's suppose gender column is my target column. Now in this target column, do we have finite set of possibilities or infinite set of possibilities? We have finite set of possibilities, right? Let's say in my office, we have people only belonging to two gender, male and female, right? So in this scenario, gender column has two possibilities. That means gender column has finite set of possibilities. So if gender column was your target column, and if in your target column you have finite set of possibilities, then your model will be called a classification model. Let's take another example. Suppose I have a column with me called stock price, and what I am doing is I am storing the price of a stock after every day. Let's say I bought a stock and the price of that stock on the first day was $100.251. After that, on the second day it was $99.7, and so on. Now in stock price column, do I have finite set of possibilities or infinite set of possibilities? If stock price column was my target column, then we would say that okay, in my target column I have unlimited set of possibilities. That means infinite set of possibilities. So if my target column has infinite set of possibilities over here, then the model that I will be building on this type of data would be called a regression model. So with this, we have covered basics of AI. I hope basics of AI was clear to you. We'll meet in next video wherein we'll try to learn something new about this course. Till then, bye guys. Thank you for attending the video, and bye.